Number 1, for each of the following functions, find the inverse function. So when we algebraically are finding the inverse functions, we're reflecting over the line y equals x, which means we switch x and y. We switch x and y and solve for y. So the first one's a nice, easy linear function. So the first thing we're going to do is we're going to switch x and y. So x equals negative 1/2 y plus 1. And I want to solve for y. So I'm going to subtract 1 from both sides. How do I deal with that 1/2? Maybe you'll deal with it in 2 steps. Maybe you'll deal with it in 1 step, but you multiply by negative 2. Notice how I'm multiplying the entire left-hand side by negative 2 to get negative 2x plus 2 equals y. So f inverse of x is negative 2x plus 2. You can verify this graphically by graphing both of these functions and seeing that they're the image under a reflection of y equals x. Big idea, though, is switch x and y, then solve again for y. So when we look at h of x, if I want to find the inverse of this function, well, you're going to have to switch x and y and get x equals 2y plus 4 to the 1/3 power. Now, there's 2 routes you can go here. Maybe you're going to say a 1/3 power is the cube root. Maybe you remember from rational exponents that that's the cube root. So how do I undo a cube root? I'm going to cube both sides. X cubed equals 2y plus 4. Or maybe you said, well, to get rid of a 1/3 power, I raise it to the reciprocal. I raise it to the 3/1 power. So I raise it to the 3rd power. So you're going to get the same in the same spot regardless of which way you go about it. But to undo a 1/3 power, you raise it to the 3rd. To undo a cube root, a 1/3 power is a cube root. You raise it to the 3rd. Subtract over the 4. Divide everyone by 2. So the final answer is h inverse is 1/2 x cubed minus 2. That's the inverse of that function there. M of x. Notice m of x is a rational function. It's a rational function because it's a fraction. It's a fraction, which means we need to be very careful with these because it has that weird process of cross-multiplying and getting our y's on one side, which we'll see. So we'll switch x and y and solve for y. So we're going to cross-multiply or multiply both sides by 4 minus 3y. We distribute that x in. Now, our goal is to get all the y's on one side and everyone without a y on the other side. So maybe you add 3x plus y over. I'm going to add 3x plus y over to that side, which means that negative 1 needs to move over to the left-hand side. So I'm going to subtract 1 from both sides. So 4x minus 1 equals 2y plus 3xy. If you got the y's on the left-hand side and everything else on the other side, your answer is going to differ by a factor of negative 1. Your answer is going to differ by a factor of negative 1. Well, now that I have my y's on this side, we GCF that y out. We GCF that y out. And then finally, to get y by itself, we divide by that quantity. We divide by 2x. 2 plus 3x. So, what's m inverse? M inverse is 4x minus 1 over 2 plus 3x. You might have a slightly different answer that's equivalent by working with a negative 1 by moving it from the numerator to the denominator, distributing it through if you got your y's on the other side. But I truly care about that you can recognize that you need to cross-multiply, distribute, group your y's on one side, everyone without a y on the other side. And finally, g of x. Well, to find the inverse, we switch x and y. Subtract 3. I can't take the 5th root yet because I need to deal with that negative 1, which is really a times negative 1. So I'm going to divide everyone by negative 1. X divided by negative 1 is negative x. Negative 3 divided by negative 1 is positive 3. Remember, negative 1 is a sign changer. How do I get rid of a fifth power? Well, I take the fifth root. So the fifth root of negative x plus 3 is 2y plus 5. I'm going to subtract the 5 over. The fifth root of negative x plus 3 is inside the radical. Minus 5 equals 2y. I don't care about 2y, so I'm going to divide that whole expression by 2 to get y. That's my final answer. That is g inverse of x there. That the fifth root of negative x plus 3 minus 5 all over 2 is g inverse. Algebraically, to find the inverse function, to reflect over the line y equals x, we switch x and y. And if k of x is the sine of x, is k inverse a function? So k of x is our favorite function, the sine function. And hopefully you remember from Unit 4, our trig unit, that sine starts at the midline, hits its maximum, hits its midline, down to its minimum, and back up to the midline. That's the standard sine function. That has a period of 2 pi and a range from negative 1 to 1. So that's one cycle of this. This function continues to oscillate on and on and on forever, and also in the negative direction. So, is this function have an inverse? Well, this function very clearly fails the horizontal line test an infinite number of times, because that horizontal line hits the sine function infinite number of times. So, it's not a function. K inverse is not a function. The inverse of sine is not a function because sine, our sine function, is not 1-to-1. That means y values repeat. Our y values repeat. Different inputs, this input here and that input there, both go to the same output. Our y values repeat, which means it's not 1-to-1. Not being 1-to-1 makes the inverse not a function. So if we tried to even switch x and y here, we would get something weird like x equals the sine of y. And that's just a weird expression to deal with. And you'll deal with that next year in pre-calc. You'll deal with that next year in pre-calc of actually finding an inverse of the function, who you can't find the inverse of now by chopping its domain. But we won't get into that this year. We need to leave something for your pre-calc teachers to teach you.